Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2019, 10B, Problem 8, and it deals with geometry. I hope you guys enjoyed this video and let's get started. The problem states the figure below shows a square in 4 equilateral triangles, with each triangle having a side lying on the side of the square, such that each triangle has side length 2 and the third vertices of the triangles meet at the center of the square. The region inside the square but outside the triangles is shaded. What is the area of the shaded region? So essentially, these are the 4 equilateral triangles that the problem talks about. And I'm trying to find the area of the shaded region. Well, what I'm going to do is I'm going to split this overall big square into 4 smaller squares. Just down through the middle. And this is going to split the 4 congruent triangles in half. So basically the altitude of the equilateral triangles would be the side length of the smaller square. So we know that the triangle has side length of 2. So that means that each smaller triangle, this has side length of 1. And then this is 2. Well, since this is a right angle because it is the altitude, and then we know that this is an equilateral triangle, so that means that this has an angle of 60, then this is a 30-60-90 triangle. And then since we know the side lengths of 2 of the sides, then we can automatically find out the side length of this, which is square root of 3. And you could do this by using the Pythagorean theorem, or you could just memorize the side length ratios for the 30-60-90 triangles. And so once we know that, we can figure out the area of this smaller triangle. So it's just 1 times the square root of 3 divided by 2, which is just square root of 3 divided by 2. So that is the area of half of the equilateral triangle. So that means that this also has an area of the square root of 3 over 2. And then we can figure out the area of the entire small square, because we know the side length of it is square root of 3. So the area of small square is just square root of 3 squared, which is just 3. And then we can use this, and then we can subtract the area of the 2 smaller right triangles from it to just get the area of the shaded region. So it's just 3 minus square root of 3. So that is the area of one of these shaded regions. Well, we're going to multiply this by 4 because there are 4 of them in all. So that gives us 12 minus 4 times the square root of 3. So the answer is B.